Hello, ladies and gentlemen, and welcome back. Welcome back. Root Beer here, looking at question number 16 on our 2017 Gauss. In the diagram, triangle PQR is equilateral and has side length 6 centimeters. Each of the shaded triangles is equilateral and has a side length of 2. What fraction of the area of triangle PQR is shaded? Alright, so this is a nice little question. You can draw our picture here. So there's a couple ways we might go about doing this particular question. Okay? So one way to do the question is to say, well, these are equilateral triangles. Everything we're talking about, the areas that we're talking about, are equilateral triangles. Right? So if you know how triangles work, if you've got similar triangles, and similar means that if I have the side lengths A, B, C, to get my other triangle, I multiply all the side lengths by some constant number. So if you understand how that works, or sort of how similarity works, and you multiply all the lengths by the same amount, you might be interested to know that area, rather than being multiplied by this nice constant number, is multiplied by r squared, and volume would be multiplied by r cubed. Now, how does that relate to this question? Well, we've got 3 of these small triangles of side length 2. I don't know exactly what their area is. Incidentally, a third way to do the question that I won't show you is just using a formula for area of an equilateral triangle in terms of its side length. If you're interested in that, I'm not going to go through it, but if you have an equilateral triangle and you want side length, its area in terms of the side length S, this is the formula for you. But not everyone in grade 8 knows that. If you do, great, and then you're off to the races. Just compute this thing with S equals 2, multiply it by 3, divide, and is it fraction we want? Or percent? Or what? Yeah, what fraction? Divide by the same formula, but with S replaced with 6. Anyway, so I think one of the few fancy ways to do the question is to notice this connection between area. So what have we got? We've got this tiny little triangle of side length 2. We'll call its area A. Well, this bigger triangle of side length 6 that is similar, well, how do we get from 2 to 6? You multiply by 3. So its area is going to be 3 squared times A. So we've got 3 A's. I've already gone over them in black. So 1, 2, 3 areas equal to A, out of the total area of the big one, 3 squared A. Well, the A's cancel out, the 3's cancel out, and you're left with 1/3. So 1/3 of the area is represented by these black triangles. So that's one way to do the question. Just real quickly, actually, I guess I brought it up. I should use the area formula. So I'll do 3 ways to do the question in this one. So we've got 3 copies of the small triangle inside 1 copy of the big triangle. Multiply by 4 on top and bottom, you'll get 3 square root of 3 times 4 divided by square root of 3, and 6 squared is 36. The root 3's will cancel out, you'll get 12 out of 36, or again, 1/3. Okay, and I had another way I want to do the question that I thought of as I was looking at it. Because to me, it almost screamed out, do something like this. If we have ever played around with equilateral triangles before, you may have seen shapes where you just sort of group equilateral triangles together and you can form bigger ones. So what have we got here? Well, we can actually see that if these triangles are placed in the black ones are placed so that they all meet in a point here, we can very nicely divide, and all these lengths are 2, so all of these triangles are nice, neat little equilateral triangles as well. So we all have the same area. And so what we've done is we've broken our big triangle, whose side length is 6, into 1, 2, 3, 4, 5, 9 triangles. And they're all the side length 2 equilateral triangles. So I've got 3 shaded out of 9 total. And this works because they're all the same triangle. They're all the same area. And so once again, we get an answer of 1/3. So there's 3 ways to do the question. I thought of 2 off the bat, and then as I was talking about it, I thought about the area formula, which you may or may not know. Either way we choose to do the question, we get an answer B. But I like it. I like it when there's lots of different ways to do the question. Maybe you know the area formula. Most people I find for grade 8 contests don't. Maybe you immediately thought to start slicing this thing up, or maybe you understood how areas and similar triangles work out, or maybe you had a different way to do it, and if you did have a different way to do it, I would love to hear about it in the comments down below. Until the next video, take care, my friends.